Hello, now let's solve practice set 1.3. Before solving practice set 1.3, let's remember number 1. If ABCD is a determinant, then determinant ABCD is equals A into D minus B into C. A into D minus B into C. Okay. Now number 2. If A1x plus B1y equals C1, A2x plus B2y equals C2 are two simultaneous equations, then by Cramer's rule D equals determinant A1 B1 A2 B2. Dx is a determinant C1 B1 C2 B2, and dy is a determinant A1 C1 A2 C2, and therefore x equals dx upon d and y equals dy upon d. Okay, these two ratios x equals dx upon d and y equals dy upon d gives us values of variables x and y in these two simultaneous equations. Now let's apply all these formulae in practice set 1.3. Practice set 1.3, question first. Fill in the blanks with correct number. Here you may note question first solution. Determinant 3, 2, 4, 5 equals 3 into 5 minus 2 into 4. That's why let's write here 3 into 5 minus 2 into 4 means A, B, C, D is a determinant, then AD minus BC. At the place of A here is 3, therefore here is 3. At the place of D here is 5, that's why we wrote here 5. At the place of B here is 2, hence we put there 2. And at the place of C here is 4, that's why here is 4. Now 3 into 5, 3 5s are 15 minus 2 4s are 8. 15 minus 8, that equals 7. Let's see question second. Find the values of the following determinants. Question second. Sub question first. Solution. Determinant is minus 1 7 2 4. We know that if ABCD is a determinant, then value of determinant ABCD equals AD minus BC. That's why that equals minus 1 into 4. Minus 1 into 4 minus, okay, A into D minus B into C means 7 into 2. 7 into 2. That equals. Now 4 into minus 1 gives us minus 4 minus 7 2s are 14. Minus 4 minus 14 gives us minus 18. Number 2, solution. Second determinant is 5 3 minus 7 0 is equals 5 into 0 minus 3 into minus 7. That equals 5 into 0 gives us 0, minus into minus gives us plus, 7 3s are 21, 0 plus 21 equals 21. Number 3, solution. Third determinant is Let's write here. Third determinant is 7 by 3, 5 by 3, 3 by 2 and 1 by 2. That equals 7 by 3 into 1 by 2 minus 5 by 3 into 3 by 2. 3 by 2. Now, those equals 7 into 1, we may write 7 upon 3 2s are 6. Sign in between them is minus. Now here 5 upon 3 into 3 upon 2. We may cancel. 3 1s are 3, 3 1s are 3. Okay. Then 5 1s are 5 upon 2 1s are 2. Now here you may note sign in between them is minus. Again denominators are not same. To equalize their denominators, we need to multiply denominator and numerator of second ratio by 3, and that's why this will become once again 7 by 6 minus 5 into 3 gives us 15 and 2 into 3 gives us 6. Means 7 by 6 minus 15 by 6. 7 minus 15 upon 6. And 7 minus 15 is nothing but 8. And sign will be minus upon 6. Numerator and denominator both are divisible by 2. Let's simplify. 2 3s are 6, 2 4s are 8, but sign must be minus. And that's why the value of this determinant is minus 4 by 3. Question third. Solve the following simultaneous equations using Cramer's rule. Question third. Sub-question first. Solution. Here, given equations are 3x minus 4y equals 10. Let's call it as number 1. It is in a form of a1x plus b1y equals c1. Similarly, second equation is 4x plus 3y equals 5. Equation second. It is in a form of a2x plus b2y equals c2. And therefore, let's write D, determinant D, a1, b1, a2, b2. That's why it will be 3 minus 4, 4, 3. That equals, now 3 into 3 gives us 3 3s are 9 minus 4 into 4, yes, minus 16. Okay, or it is better to write initially in a multiplication form like this: 3 into 3 minus 4 into 4. Okay, that equals 9 minus into minus plus 4 4s are 16. 9 plus 16 gives us 25. Number 1. Let's find dx and dy. Dx equals, we learned that dx is c1 b1, c2 b2 is the determinant dx. That's why here we may write 10 minus 4, 5, 3, because c1 is 10, c2 is 5. That's why we wrote like this. Okay, equals 10 into 3 minus 4 into 5. Okay, equals 10 3s are 30, minus into minus plus 5 4s are 20, and 30 plus 20 gives us 50. This is the value of dx. Similarly, let's find dy. Dy is a1 c1 a2 c2. a1 is 3, c1 is 10, a2 is 4, and c2 is 5. That's why that equals 3 into 5 minus 10 into 4. Okay, those equals 3 5s are 15 minus 10 4s are 40. 15 minus 40 gives us, now 40 cannot be subtracted through 15, but 15 can be subtracted through 40. 10 minus 5 gives us 5, 3 minus 1 gives us 2, and sign will be minus for that. Okay, now this is the value of dy. Let's call these as number 1, number 2 and number 3. Now by Cramer's rule, x equals dx upon d equals, value of dx is 50, value of d is 25, 25 ones are 25, 25 twos are 50, x equal to 2. Similarly, y equals dy upon d, value of dy is minus 25 upon value of d is 25, 25 ones are 25, 25 ones are 25, but sign must be minus, that's why it will be minus 1, and therefore solution set x comma y is 2 comma minus 1. 2 minus 1 is the solution of first pair of simultaneous equations. Sub question second. Solution. Here 4x plus 3y minus 4 equal to 0. Now it is not in a form of a1x plus b1y equals c1. First of all, let's convert it in that form. That is a1x plus b1y equals c1. And therefore it would 4x plus 3y equal to 4. Let's call it as equation first. Okay. Then second equation is 6x equals 8 minus 5y, and therefore 6x plus 5y equal to 8. Equation second. Now D is a determinant a1 b1 a2 b2, that must be equals. Now here in this case a1 b1 a2 b2 means 4 3 6 5. Okay, and that gives us, that is equals 4 into 5 minus 3 into 6. Okay, which gives us again 4 5s are 20 minus 6 3s are 18, and 20 minus 18 nothing but 2. Let's call equation third. Dx is a determinant c1 b1 c2 b2. Okay, now here c1 is 4 and c2 is 8. Okay, that's why let's put at the places of c1 and c2 as 4 and 8 respectively. b1 is 3 and b2 is 5. That's why at the places of b1 b2 let's write 3 and 5. 4 3 8 5 is the determinant dx. That equals 4 into 5 minus 3 into 8. Okay, 4 5s are 20 minus 8 3s are 24. 20 minus 24 minus 4, equation 4. Similarly, let's find dy. dy equals determinant a1 c1 a2 c2 that equals A1 A2 and C1 C2. We are interested with those. A1 is 4, A1 is 4, C1 is 8. Sorry, A1 is 4, C1 is 4. Okay. A2 is a 6, C2 is 8. A2 is 6, C2 is 8. That equals 4 into 8 minus 4 into 6. Okay, 8 4s are 32 minus 6 4s are 24. 32 minus 24 gives us 8. Equation 5th. This is the value of dy. Now, by Cramer's method, yes, by Cramer's method, x equals dx upon d, that equals value of dx is minus 4 upon value of d is 2. Minus 4 upon 2 gives us minus 2. Y is dy by d, that equals dy is 8 and d is 2. 2 1s are 2, 2 4s are 8. And therefore solution set is xy must be minus 2 comma 4. Similarly, in question 3rd, solution here x plus 2y equals minus 1. Equation first. 2x minus 3y equals 12. These are in the form of a1x plus b1y equals c1 and a2x plus b2y equals c2. And therefore, by Cramer's rule, d is a determinant a1 b1, a2 b2, that equals a1 is 1, b1 is 2. That's why 1 2. a2 is a 2, b2 is minus 3. That's why we are writing here 2 minus 3. That equals 1 into minus 3 minus 2 into 2. Okay, 1 into minus 3 minus 3 minus 2 into 2 minus 4, and minus 3 minus 4 gives us minus 7. Let's call equation 3rd. Dx is equals c1 b1 c2 b2. c1 is minus 1, b1 is 2, c2 is 12 and b2 is minus 3. That's why determinant minus 1 to 12 minus 3, that equals minus 1 into minus 3 minus 2 into 12. That equals minus 1 into minus 3 minus into minus plus 1 into 3 3 minus 2 into 12 minus 24, and 3 minus 24 gives us minus 21. Equation 4th. Similarly, dy is a determinant a1 c1 a2 c2. That equals a1 is 1, c1 is minus 1. 1 minus 1. a2 is a 2 and c2 is a 12. 2 comma 12. That equals 1 into 12 minus minus 1 into 2. 12 ones are 12, minus into minus plus, 2 ones are 2. 12 plus 2 gives us 14. Equation 5th. Now, by Cramer's rule, x equals dx upon d. Value of dx is minus 21. Value of d is minus 7. Minus minus become plus. 7 ones are 7, 7 threes are 21. Y equals dy upon d equals, value of dy is 14 and value of d is minus 7. 7 twos are 14. 7 ones are 7, 7 twos are 14, but sign will be minus. Therefore, x comma y is 3 comma minus 2. Okay. Similarly, we can solve rest of the sums.